Hello again, integrated Math 1 students. This is Mrs. Kaufman, and again, we're going to look at another way of looking at system of equations and using that elimination method. So here I have another example of two equations in a system of equations, 4x plus 3y is equal to 10, and 9x minus 4y is equal to 1. And if I was to, let me see if I can move these down. Oh, still not going to let me do it. All right, I'm going to rewrite these over here. I have 4x plus 3y is equal to 10. And can I use elimination method to get rid of or eliminate one of these variables? So when I'm using elimination method, remember I'm adding down. So I get 9 plus 4x is 13x. 3x minus 4x is negative 1x, or 1y, excuse me, and 10 plus 1 is 11. So again, I'm not able to use my elimination method. So because one of the variables is not going away. Well, what if I multiplied one of these by one variable? Would that work? That's what we did yesterday in Monday's video. Which one would I do? Well, remember how I kind of thought about it yesterday? I said, okay, so let's look at this negative 4. What can I multiply this negative 3 by to get a negative 4? That's not going to work either. Well, what about 9? If I multiply this 9 by maybe a negative number, would it give me negative 4? Or that 4, if I multiply that 4 by a negative number, would it give me 9? And of course, I can't think of any that would do that either. But what if I try to multiply both equations by different numbers? That will allow us to rewrite this equation and use the elimination method. Okay, so here's my attempt. I'm going to multiply the top one by 4. So let's go ahead and do that now. So 4 times 4 is 16x. 4 times 3y is 12y, and 4 times 10 is 40. Now I'm going to multiply the bottom equation by 3. So if I multiply it by 3, I get 3 times 9 is 27x. 3 times negative 4y is negative 12y, and 3 times 1 is 3. Now I see where my variable is going to be eliminated. So if I add down, I get 16 plus 27, which is 43. But 12y minus 12y, well, that's just 0, is equal to 40 plus 3, which is 43. Well, now I can solve for x. So that's what it asks us to do, is go ahead and solve for x and y. So 43x is equal to 43. I just got rid of that 0, right? So I'm going to divide both sides by 43, and x is equal to 1. So now to find y, I should be able to put it into any of these 4 equations, right? Because remember, these two original equations were just multiplied consistently on both sides of the equal sign by a number. So let's do that now. Let's take the top one here. Let's take 16x. I know what x is. X is 1. Plus 12y is equal to 40. Can you tell I'm at school? 16 times 1 is 16, plus 12y is equal to 40. Now I'm just going to solve for y. I'm going to subtract 16 from both sides. I have 12y is equal to 24, excuse me. I'm going to divide both sides by 12. Y is equal to 2. So there's my solutions. So my solutions for this equation, system of equations, is x is equal to 1, y is equal to 2. And remember, I don't think I reminded you in the last video, but you can also make it a coordinate point, because remember, this is where our two lines meet at 1 and 2. Okay, so that was just another method of using elimination, but by multiplying both equations by different numbers to give us that variable to be eliminated. So here's another example. So I have 2x plus y, 3y is equal to 20. I have 7x plus 2y is equal to 53. Which one do I want, what numbers do I want to multiply by so I can eliminate either the x's or the y's? Well, there's a couple ways we can do it. I think the way that makes it easier for me to think about it is I'm going to multiply this top one by -2 and this bottom one I'm going to multiply by -3. The goal is to get this to positive 3. The goal is to get this to -6y and positive 6y. All right, let's do that. So my top equation, if I multiply -2 times 2x, I get -4x. If I multiply -2 times 3y, I get -6y is equal to -2 times 20 is -40. For my bottom equation, if I multiply 7 times positive 3, I get 21x. If I multiply 3 times 2y, I get positive 6y. And 3 times 53 is equal to 159. All right, it looks like I'm going to be able to eliminate my y's. So I'm going to add down, and I get 21 minus 4. (17x). 6y minus 6y, -6y plus 6y is plus 0. That's what I got eliminated. And then we got that 59 minus 40, which is 119. All right, now I can solve for x. So if I go down here, if I divide both sides by 17, I end up with x is equal to 7. Now I just need to find that y value, because now I know my x is equal to 7. We can use either of these equations. You can use any 4 of these equations to find that y value, right? So which one shall we use? Well, let's use this one. So we have -4. Remember, I know what x is. I'm finding y. So -4 times 7 minus 6y is equal to -40. So -4 times 7 is -28. Minus 6y is equal to -40. I'm going to add 28 to both sides, and I get -6y is equal to 12. Actually, -12. Then I'm going to divide -6 by both sides. Y is equal to +2. So there's my other solution, my other part of my solution. X is equal to 7, y is equal to 2. Or again, you can put it in coordinate form, because remember, this is where those two lines cross or meet. All right, so this is just another method of solving elimination. If we can't eliminate immediately, we multiply either the top, or we multiply the top or the bottom in order to eliminate an x or y and solve. If you have any questions, please reach out to your teacher. Otherwise, I'll see you in the next video.